At DTCo, we value the personal development of our designers. So recently we arranged for a few of our designers to go to FusionWorks, a fabrication shop in North Melbourne, to gain valuable exposure to the manufacturing process and allow them to gain hands-on experience in welding. I had the opportunity to sit down with Af, one of the mechanical designers here at DTCo, and Nigel, the owner and operator of FusionWorks, to gain their insights into the experience and understand how enhancing the knowledge of mechanical designers about workshop operations can positively impact their design skills. So hello Af, welcome, it's great to have you. To start us off, I was just wondering if you could provide an insight into how the exposure to the fabrication workshop at FusionWorks influenced your approach to designing products for our clients.
It's made me more aware of the minutiae of the fabrication process, especially when it comes to welding. It's given me a better understanding of how designs can be made easier to manufacture.
And so how does the understanding of fabrication techniques affect your ability to create designs that are practical and feasible to manufacture?
It gives you an understanding of what considerations you need to give for each technique and what type of tolerances are feasible for which processes.
So could you name some of the main advantages of having first-hand knowledge of fabrication and welding when designing products? And how does it improve your abilities as a mechanical designer?
Without first-hand knowledge, you may not be able to give proper consideration for stuff like the welding process, like leaving enough space for the weld gun to reach certain areas. So it definitely gives you another tool you can use to improve your design.
So now, given your recent exposure at FusionWorks, how has this expanded your perspective, and what valuable lesson or insight will you carry forward with you into your future projects?
Having been a part of it, it's given me a newfound respect for the manufacturers and fabricators. So moving forward, I'll give even more consideration to how I can make their work easier by implementing better design techniques.
And lastly, just to wrap up, I was hoping you could share with me one thing that you learned from your time in the fabrication workshop that would help you produce better manufacturing information going forward.
I think one of the things I learned is sometimes it's much easier to weld something on than fasten it with multiple nuts and bolts. I think in my future designs, I'll be using a lot more welding where it's appropriate.
Hello, Nigel. It's great to see you. Would you mind just briefly introducing yourself?
So I'm Nigel King. I run FusionWorks. We work with varied clients, but the last couple of years, we tried to narrow them down a bit. We're tradesmen, we're not engineers, and we do usually quirky one-off projects for people.
So to start us off, in your experience, what can engineers gain from working in a fabrication shop and gaining hands-on experience with the manufacturing process?
A better understanding of how things are put together and why they're put together in that sort of way. I think you can get designers, do it myself, you can get pretty focused on a computer. The way you model stuff and how you put things together is different to the way things are modeled. Doing it, you learn so much just by doing things. And, why so if you've drawn it like that to get that result, how do you actually get from A to B in a practical sense? It's not until you actually have to do it. Oh, right, that's how big a standard is. Oh, that's how big a thing. Oh, really, it's really hard to drill.
Yeah, that's understandable. So in your opinion, which specific areas of manufacturing and or fabrication exposure do you consider to be the most valuable for a mechanical engineer when it comes to enhancing their engineering skill set?
Fabrication. So welding is a skill and an art, but just having an idea of where the fabricator puts his welds and why they put these welds, I reckon's invaluable, and how he actually starts. Af and Michael we spoke about that as we went through. We actually had the drawing package in both digitally and on paper form. I says, you don't actually start from page 1, you actually start from page 3, and then you're wading through a whole bunch of information to get the information you actually need to do your cutting list. As a rule, fabricators are quite tangible, they're hands-on. They can't see it until it's made, until the bits are on the shelf. So 3D drawings are terrific, but you don't need all the parts. You almost need to break it down into a set. Make this first, and now you've got a sense of that, and now it's going to look like this, and now it's going to look like that. When your guys were here, we actually talked and workshopped a lot of that to do with it, because they're wading through, what size bolts were we used to put the casters on? Well, the frame's not even made. It's not even made yet. What's the bolt centers of the base plates at the bottom? Let's not wait for that until we've got until we've got the outer all frame made.
So Af brought up, for example, how he's more aware of the size of tools like a weld gun, and how if, for example, a type of weld is required in his design is going to need to consider how that tool of that size will fit and reach the location of the desired weld. Is this the type of knowledge you're referring to?
That's really true. That's a really good point he picked up, because we do it all day, every day. So you get a different take on the same thing. So in terms of, you don't put a weld right in the corner because it takes you twice as long to clean out a weld that's right in the corner. So if you leave it a grinding disc diameter out from the corner, you can scrub across with a grinder. Whereas you have to use the die, if it's right in the corner, you have to use the die grinder to clean it up and take all the spatter and things out. So there's a whole bunch of little things like that, little nuances.
So next, I was hoping you could provide us with an example of an instance where an engineer's understanding of the manufacturing process has resulted in design improvements or cost savings.
I can give you plenty of examples where it's cost them a lot more money. Normally the best result is your designer comes down and has an understanding. So you guys do it anyway. What's your meetings called? Design reviews. Having a fabricator in a design review process, it won't catch everything, but it'll catch a lot. And you'll get that bit of overlap in a design review. So if the engineer's got an understanding of how things are built, I think you're going to catch a lot more in your design review. By doing things and having a fabrication consideration, things get optimized, which means it's cheaper and easier and better.
And so then carrying on, how can this exposure contribute to the overall efficiency and quality of the manufacturing process from a design perspective?
It's mainly the complexity of the drawings. They can be too hard to wade through and find dimensions usually. If designers had a better understanding of what fabricators are looking for, I think that's a good thing.
And lastly, to wrap up, I guess I want to know, how did our guys go in the workshop?
They worked really well, and they were really engaged, and I genuinely think they really enjoyed it. Because it's a tough, as a rule, when you go to school or pick your career, you think, oh, do I want to be dirty, or do I want to sit in the office? And most of the guys that sit in the office don't really want to be slobbing around fab shops, but I think they genuinely liked it. It's actually quite fun seeing the things, and most people that work in this industry, you get the joy or the fulfillment in your career and your job is seeing a drawing to a bunch of things, to something created right in front of your eyes. It takes shape and it moves and it evolves, and you can see it and touch it and move it, and you can say, I made that and I made a mistake here, but I nailed this section here, or I optimised this bit there and it made it a hell of a lot better. So, but yeah, and I think they got all of that out of the experience. And they, as I said, they were welding and they were cutting, and they got right into it. It was good.